Alright, so we are now on our second lecture for Python, and I'm going to go ahead and open my command window and open idle so that we can get going. And then I'm going to go ahead and open up that recent file, that first Python command. Oh, there's all stuff I was already working on there. So here we have the python.py file. I will not shrink down. And we also have the interpreter window. It's kind of like the command window in MATLAB. And like I was just saying, one of the things you want to check to make sure that everything worked on your install is if you go ahead and type import numpy, make sure that it doesn't give an error, that it can find it. And then you can also try import matplotlib and then make sure that it imports that. Those are the two most important modules that we're going to be using more. Okay? All right. So I want to go over control structures here. That's one thing about print. The print statement. I do realize that one of the links that I gave you for the list, defining the lists, it actually has print statements where it says to do this, where you print and then a space, and that's actually, there's an older version, Python 2. And in Python 2, you printed things with print space and then whatever you wanted to print. And you can't do that anymore in Python 3. In Python 3, you need to do print like a function and pass to that function whatever you want to print, whether that happens to be a number or a string or the value of a variable or whatever. Okay, so if you ever see print space and then something, that's old Python 2 syntax. So you can need print and then parentheses whatever you want to print. Okay, so that's one thing to keep in mind. Now, for loops. If we wanted to do a for loop, good old standard, have a loop for I going from, say, 0 to 9 or 10 or whatever. Okay, it's kind of weird the way you would have to do it. Okay, and this looks a little strange, but it gives essentially what we want. Okay, and this is like, for int I, int is less than 5, I plus plus, right? Okay, this gives, that type of a thing. And now, what's really interesting in Python is that for loops are fundamentally different than any other for loop you've seen. They're amazingly flexible, okay? And you can do lots of really cool things with the for loops in Python. You may never actually use the functionality of them. They're there. I mean, what you're most used to is I need to do some sort of a for loop like this where I have some number and it needs to increment every time through the loop. Okay, that's what you're used to. And even in MATLAB, you've been kind of used to that. When you do for I equals 0 colon 4, that's how you would do the for loop in MATLAB. There's actually more stuff you can do in MATLAB as well than just this, but in Python it's even more. What's curious, first of all, is this for I in. At first, when I was first learning these for loops, I'm like, for I in, what does this in mean? Why do they use the word in? Why isn't it like an equal sign or something like that, okay? And that lends itself to the concept of what a for loop is in Python, is it will loop through any so-called iterable, anything that's an iterable. So this thing right here is what we call an iterable. And it can be anything. Now, the function range, what range returns, if I say y is equal to range 5, okay? So, oh, come on, really? It does that? That's really annoying. So, what is the type of y? That's really interesting. What is y's type? It is, so apparently there is a range. Isn't that curious? Well, let me do it in a different way then. Let me do this 0, 1, 2, 3, 4. That should do the same thing. Well, that's really curious. You know, I've been doing Python for, I don't know, a year and a half or so, and I learn stuff all the time. Just like I've been doing MATLAB forever, and I still learn, students always teach me new things. Apparently, there is a class called a range, and I don't know, it has all sort of special things. But what I've learned to think of as range is like the colon operator in MATLAB, that it will start at 0. If you give it just one input argument, it will start at 0 and go up to but not include the number that's there. Okay? And let me do another one here, range 1, 5. So if I do range 1, 5, it will start at 1 and go up to but not include 5. So you can say what you want to start with, what you want to end with, and you can also actually say what step size you want. Let's say I want to go step size of 3. And so if I run that, you know, that's like 1:3:15 in MATLAB. So it's just sort of switched. It's first number, end number, step size. So I think of range like the colon operator in MATLAB. Okay? And I was thinking incorrectly that range would return a list with those numbers in it, but it returns an instance of the range class, which is kind of odd. So now we all need to go and look up what the heck is a range class. But in the end, you don't really need to know that. What you need to know is basically in your for loop, this thing here will do what the colon operator does for you in MATLAB. Yes, Rusty?
On the first line, the very last symbol, what does that do?
Yes, that's a very important thing. There's this semicolon, okay? And that brings me to another very curious, very different thing in Python, that not all white space is ignored in Python, okay? What the colon says is that you're going to begin a block of code, kind of like this curly braces for C++. The curly braces says, I'm going to begin a block of code, and then you have a curly brace at the end to say this is where that block of code ends, right? You may not have really thought about it that way, but that's what the curly braces do, is they take a block of code and they package it into one thing, okay? And so the colon in Python is like the begin curly brace. But you have no end curly brace because blocks of code in Python are signified by spaces or tabs, okay? So you can't do this. This, I'm not sure what will happen, but it shouldn't do what, yeah, it gives you an error. You try and run it, it says expected an indented block because you told the computer there's a colon here. So I'm gonna start a block of code, but then you never put an indentation. Okay, so you have to have an indentation there. Either you can do a tab or you can do some spaces, but you have to have an indentation for that to run.
It needs the white space.
It needs the white space. White space is not ignored in Python necessarily. Okay, so that's really important in Python, that you start your block with a colon and then whatever comes after that. So if I do print I and print I, well, let me do this, 2 times I and 2 times I and 3 times I. So what this is, these two statements are inside the for loop because they are indented in the block. Okay, this line is not in the for loop because it's not indented. All right, so it takes a little while to get used to this. It's a little strange that indentations actually matter, but you know, I think this is a good thing because I come around and look at your guys' code in C++ and there's no indentations and there's curly braces wherever the heck you want them to be, and sort of this forces you to format the code to look nice. You have to, or else it won't work. In C++, it'll work if you don't make it look nice. What's that?
How dare.
How dare they force me to make it? This is the infringement on my individual rights. I can make my code look crappy if I want to. No, unfortunately in Python you must make it look nice. Now, they still argue over things. Some people will argue whether you're supposed to put a tab there or if you're supposed to put 4 spaces. So that's sort of like the argument over style, is whether they should be spaces or whether they should be tabs. So that's what people argue about in Python, is whether they're tabs or spaces.
Does that take out a different like amount of code?
I'm not sure. I should probably look in why that is such a vigorous debate, but it is. Like Google, you know, they have a style sheet for how you should write your Python code, and they insist in their style that it's spaces and it's not tabs. You know, so I don't know. Every computer scientists have to have something to argue about, right? So they'll find anything. Okay. Yes.
Would you indent a nested for?
Yes. So if I was going to have a nested for loop, then I would have to have it here, and then I have j in range of whatever, and then the stuff that's inside the j loop would be here, and then this would be inside only the I loop and not inside the j loop. So yes. So let me go ahead and run this program. We never did run it. So you can see what happens. So it does 1 and then 2 times 1, 4 and then 2 times 4, 7, 2 times 7, 10, 2 times 10. Then it does 13, right? And 2 times 13. And then when it adds 3, it gets to 16. So then the loop is ended because I was only supposed to go up to 14. Okay? And then I take the 13 that was in the I the last time, and when it exits the loop, I is still 13, and then it gets multiplied by 3 to be 39. Okay? So this is not inside the loop. These ones are inside the loop because of the indentation. Okay? Yes?
Would there be a way to, I guess, hide the, like if you just wanted the 3 times I
Okay.
to break out and not display the I's?
Yes, so you're saying if we wanted to only have this thing printed but not print these things?
Right. I guess is there a way to like just in MATLAB where you just commented it out or made it not print?
Oh, I see. That you want to do something but not display it on the
Right.
screen.
That's
So like in MATLAB where you put semicolon to suppress output.
Right.
Okay, well print will print it out on the screen. So, but I could do, you know, if I do 2 times I or set x equal to 2 times I, that will not print on the screen. Okay?
Okay.
So if you want something to print on the screen, you have to write print. If you don't write print, it won't print anything, whether, you know, there's no such thing as a semicolon or no semicolon. So this line of code will never print anything on the screen for you unless you type print.
Okay.
Just as an added, how do we comment out? Same way as before?
You comment out with pound symbol.
Thank you.
Pound symbol comments, and if you want to do a multi-line comment, you do triple single quotes. So that comment, anything between triple single quotes will be commented out. That's like backslash asterisk asterisk backslash in C++. Okay. One other comment about strings. I don't remember if I said before, but strings in Python, you can either use single quotes or you can use double quotes. Either one. And I'm sure there must be a vigorous debate over whether you should use single or double.
I think there's like an issue, like if you have an apostrophe in there. That's what the double
Yeah, okay, so if you want to, yeah, right. So if you want to have an apostrophe, you would have to use you could use that. And I guess maybe the opposite true. If you wanted double quotes, you would use a single one and a double, maybe. Yeah, maybe that's why they did that, so that you can have single quotes and double quotes in your string. You just have to switch which one is on the outside.
You'd have to use the forward slash.
Yeah, in other language you have to do like a forward slash before it to signal that it's not the end of the string, but rather be inside it. So apparently you don't need to do that in Python. You just switch around. What's that?
So you get my email?
I did. Yes, Joe sent an email about some apps, some Python and other programming learning apps that sound really cool. Maybe
That's why I
I'll
learned
okay.
why it's like that.
Okay, cool. So maybe I need to. Maybe I'll post these apps that Joseph has found in the news that you guys can go and check out. So it was really good idea. Okay, so this is how you would do a loop like you're used to doing a loop. We're going to have a number, and it's going to start at some number, and it's going to go up to some number, you know, and you're going to do, you know, loop through different numbers. Okay, Python allows you to do so much more. Okay? So you'll notice I had done one thing earlier where I replaced range with a list of numbers. Okay? And a list is an iterable, just like a range apparently is an iterable, so is a list an iterable. And so what it does here is I've got this list of different numbers, and it alternatively will take I will first be 1, then I will be 2, then I will be 3, then I will be 4, then I will be 5. Okay? And you could actually change this list around. I could have it be, numbers in different orders. They don't have to all be in order. I can have whatever I want in this list. And it'll go through them in the order that they are in the list. Okay? And actually, you can do this in MATLAB too. You may not have realized it because you're so used to doing, in MATLAB for I equals 1 colon 10. You can also do for I equals 5, 4, 3, 2, 1, and it'll start off at 5 and then do 4, or they can be in whatever order. It can also it'll loop through each of the things in there. And you may not have known that in MATLAB, but you can do that. Okay? You can do that in Python as well. Okay? But you can do so much more. Anything that is an iterable, you can have in your for loops. Let me go ahead and run this. You can see, it does that. Okay? Anything that's an iterable. Strings, for example, are iterables. Okay? And if I run this, it will first get the W. I will first be the W, then the R, then the E, then the G, etc. Okay? And so now it's starting to make sense why they use the word in. For I, that's going to be the variable that changes through the loop. I is going to be in. It's going to be stuff that's inside that iterable that comes after it. So I is going to get the values in the iterable that follows. So now it makes a little bit more sense why they're using the word in their for loop. Okay? Now, here's a really cool thing, okay? This list that is here need not be a list of simple things. It can be a list of lists. I'll have a list of the numbers with 1 and 2, then a list of the numbers 3 and 4, then a list of the numbers 5 and 6. Okay? So now I have a list of lists. So I is first going to be the first element in the list, then the second element in the list, then the third element in the list. So when we run this, I becomes a list, the list 1 and 2, then the list 2, 3 and 4, then the list 5 and 6. That's really neat. Okay? So it's not just, and it could be anything. I mean, this thing could, that could be just the number 5, because remember, lists don't have to all have the same data type. And if I do that, sometimes I is a list and sometimes I is an integer, which is kind of neat. Okay? So the for loops in Python are much more flexible than what you're used to in other programming languages. Okay? Now, here's something that's really cool. Okay, so this is really neat that you can have loop control more than one loop control variable. I mean, they're not even loop control variables anymore. It's not even right to call it that. I wonder what they call that thing in a for loop. I should look that up. I know they call this the iterable, but this is not what controls the loop anymore. It's getting values in there. So this is really cool that the first time through the loop, it assigns 1 to I and 2 to j. Then the next time through the loop, it assigns 3 to I and 4 to j. Then the third time through the loop, it assigns 5 to I and 6 to j, which is really neat. So for example, if this thing here happens to be a list of, say, ordered pairs of points, then I could loop through this list of ordered pairs and pull out the x and y components in each one of those ordered pairs. And so, doing that in another language would be trickier. You'd have to index things out and pull out the x individually and the y individually. It would be trickier. So you can do some really, really neat things in Python with these for loops, okay? Now, you know, it's sort of like Adam asked the other day before the test. He's like, should I worry about learning how to do all these MATLAB-y-like functions? I'm like, well, no, you can do your nested for loops to go through your matrix rather than learning element-wise operations. You know, it might take you longer, but there's no reason why you can't do that. In the same way, you know, just using the basic vanilla for loop with the range in there, you can do all the things you're used to doing in other ways, but you're not taking advantage of all the things that Python has to offer you. And I must say, you know, even 1 year and a year and a half in of using Python, I still do things the way I'm used to and not using all of the things that Python has, you know, but as I use Python more and more, I get more comfortable using all these extra bells and whistles. Okay? All right. How about if statements? If, okay? And the if statements don't require parentheses like they do in C++. In MATLAB, you don't need parentheses either. So if is kind of like a function almost in C++, but here you can just put a space. You don't have to put anything. Then I can say, you know, for example, if I is equal to 3, okay, then maybe I will print something, it is 3. Now you'll notice one of the other nice things, when I put the colon on here and hit enter, it automatically indented for me. Okay, let me show you. Let me show you that again, actually. Okay, and I hit colon to say I want to start a block of code, so everything that comes after this that's indented is going to be part of the if statement. So I hit enter, it automatically indents it for me. Okay, so that's kind of nice. Okay. And so now what it's going to do, it's going to loop through, it's going to print the i's and the j's, and if I happens to be 3, okay, then it's going to print out that. So here I get, you know, 1 and 2, 3 and 4, yes, it's 3, then 5 and 6. Okay? Then if we want to do an else statement, I need to go back to go undo the indentation. Okay, and again, I need to start a block of code for my else. Okay, so now it's going to print something every time, whether it's 3 or whether it's not 3. Okay, so your else is going to also have a colon there. So it takes a while. It took me a while. I would always forget. I'd hit enter and I wouldn't have colons, and it wouldn't indent for me. You know, so that's sort of a clue that you did something wrong. If you hit enter and it doesn't indent automatically, like, oh, that's right, I forgot to put in my colon. Okay. Then we can do else if. Else if. It's called elif. Okay. Elif I is equal to 2, then write print it is, well, it is never 2, is it? Let's make it 5. It is 5. Okay. Else print not 3. So here's how you do an else if then else if then else. Okay, pretty straightforward. It's one of those things you got to learn the syntax of a new programming language. Okay. All right. While loops are really, really simple. Oh, I was putting a semicolon on there. It's force of habit. While count is less than 5, and again you need to have a colon. Okay, print count plus, I think it has plus equals. I'm not sure. Let's find out. Yes, it does have plus equals. Okay, so while loop's really simple, you put whatever Boolean statement is going to make that loop continue, and then you need a colon to make sure that you define your block of code, and then whatever is indented is going to be inside the while loop, and then whatever is not indented is not going to be inside the while loop. Okay.
Just out of curiosity, is there any chance count plus plus works?
I don't think so. Let's try. No.
Okay, thank you.
Unfortunately, no count plus plus. Okay? So that's all pretty straightforward. The biggest thing is those for loops can do really weird and interesting things, but if you're trying to do just vanilla stuff, just do range. And that'll get you started, and you can do all the loops in the way that you're used to. Okay? All right, we have some more time. Let's go ahead and talk about functions, defining functions. So, to define a function, you say def to define the function, and then you say the name of the function, and then you say what are the input values for that function. And then you start a block of code. Okay? So then I can say print, or I can do x is equal to x squared, and then I can do print x. Okay? And then in my code down here, let me go ahead and I'll just comment this out for now. Okay. So the function is defined there, and then if I want to call the function, I'll call it myfunc3, myfunc5, etc. Okay, so first it calls myfunc, passes 3 in, 3 gets squared. It didn't get squared. Ah, the caret must not, that's right, it's not caret. What the heck does caret do in Python? Yeah, it's times. Old, I need to go back to Pascal. That's what I took when I took AP Computer Science in high school. I did Pascal, and that's the times is for the power. Gosh, I need to know. Do you know what does the caret do in Python? I'm not sure. We'll have to go. It must do something. There we go. Now we got 9 and 25. Okay, so times. Pow does also work, I'm pretty sure. Let me double check that. So those of you, yeah, pow works as well. Or you can do the time. I like the times better. Okay. So we're defining my function, having that thing go and print out my stuff. Okay. If I want to return something, okay, let's say I wanted to return that. So now I can return x. And then if I want to catch it, I need to say y is equal to that. Okay. So here I'm calling myfunc, I'm passing in 3, it gets squared to 9, it gets printed inside the function, and then the 3 gets returned, but it's not caught anywhere. Nothing happens with that one that's returned. But then I call it again, passing a 5 in, 5 gets squared to 25, 25 gets printed, the 25 gets returned and caught in the variable y, and then I print y, and that's why I get the 2 25s. Okay? Another wonderful thing is that Python can return 2 things. Okay, let me do this. Let me change this to... Actually, the print statement's really not all that useful in there. If I want to return 2 things, I just separate them by commas. Okay? And if I want to catch them both, I separate them by commas. Okay, so now it's returning the original x, and it's returning that x squared, and they're being stored in the variables x and y in my main scope. Okay, this function does have its own scope. It has its own local scope like any good programming language does. And so here I'm able to return multiple things. Okay, really nice. You don't have to worry about the data types. I mean, x and y, they can be lists, they can be whatever. You know, it's really nice. It's easy. You don't have to, you know, in your function prototype, you don't have to say, well, I'm going to return a double, or I'm going to return a pointer to a double, or whatever. You just send it back, and it'll get caught and be written into whatever variable's there. Okay? Let's pass multiple values. Let's do this where we'll pass x and y, and we'll return x raised to the y power. Okay, so now only one thing is being returned. I'll call it pow. Well, power. So I'll pass 5 and 2. 5 squared, then of course is going to be 25. Nope, what did I do wrong? This one here, this call to my function is only passing one thing. It needs to pass 2. It's expecting 2. Okay, so that should run. There we go, we get 25. Okay. I don't know, have you guys ever done default arguments in functions? You guys ever do that in C++? Anybody heard of that? Default parameters, default arguments?
We used it in case statements.
Okay. Well, let's say we wanted to be able to call myfunc and only pass 1, and if, let's do this, base exponent, base, and so now this is no different than it was before. Okay, I just renamed it to base and exponent, and let's say we say, well, if the user doesn't pass me an exponent, I'm just going to assume that they wanted 2. Okay? So if they only pass one thing, then they're going to assume that the exponent is 2. Okay? But if they do pass a second thing, they'll use that exponent. That's why, and then we get 125, 5 cubed. So that's kind of neat that you can have default arguments. So if you don't pass that argument to the function, then it'll assume 2. Okay. Now I'm going to take that off for right now to show you another thing that's really interesting, and I'm not sure I've ever seen this in another language. But let's say for whatever reason you wanted to pass first the exponent and then the base. I mean, normally that wouldn't work because it's defined to first take the base and then the exponent. Okay? But if you wanted to, you could declare here to say, hey, you know what? I want this one to be the exponent, and I want this one to be the base. Which is really interesting, is that in your function call, you can give the input arguments in a different order than what they're defined, as long as you tell them which one is which. Okay, so this is kind of weird. If you do this with the equal sign, passing something in, this is the name in the local scope of the function, and this is something in the current scope. So for example, if I did b equals 5 and e equals 3, I would do this. I would make that e and this be b. So the first one is the name of the variable in the scope of the function. The second is the name of the variable in the scope of the calling, in the calling scope. So this is kind of interesting that you can do this. Okay? And I think, I don't know, this is my speculation. I think the reason they do this is because many functions in Python might have lots of input arguments, and many of them might have default values. And if you want to change, if you want to pass, say, maybe the 10th default, change the 10th default value, but leave the other 9 unchanged, in other languages, you'd have to pass all of those values, the first 9, if you wanted to pass the 10th one. And here you're able to say, I only want to change that 10th one. I think that's probably why they've done this. It's kind of neat, but I haven't seen it be all that necessary. Okay? But you can change the order of what you pass them. You just have to tell them which one is which. Okay? All right. Another thing I want to warn you about, and I warned you briefly about this, okay, but I want to hit it again. Okay, let's say we have a function that inputs a list, and let's say I'm going to change the third index of that list to be the number 5. Okay, and I'm going to print inside function and input list. Okay. And then here, I'm now going to say my list is equal to 1, 2, 3, 4, 5. And I'm going to print before function my list, and I'm then going to call my list function by passing to it my list, and then I'm going to print after function my list and run this. Okay, so there's no problem here. It did what we would expect it to. Okay, I passed my list in. I changed the third element in the local scope of the function, and in its local scope, the third one. No, it didn't do what I wanted. Yeah, right. Okay. What's that? Yes, it is number 3. So before I go, it's 1, 2, 3, 4, 5. Then in the local scope, I change the index 3, the fourth one, to be 5 instead of 4. Okay, and then Then I come back outside, and I print after the function in the global scope. This is the global scope, and now I printed the list in the global scope, and the value is changed. This is not what you would expect. Because normally you pass something in and you change it inside the local scope of the function. It shouldn't change outside. Right? You're not used to that. And that has to do with this thing about the copies and the deep copies, and that a variable is, when you copy one thing to another, it copies the pointer to that or the reference to it. Okay? And so when I change this one element, okay, input list here is actually pointing to the same memory that my list is. And so when I change one of the elements in there, it's going to change it when I come back outside the function. Okay? So normally you would not expect this to happen. You would not expect changing something inside the function to affect something in the global scope. Okay? So you would need to use that copy thing. So if I import copy, and then I could say copy list is equal to copy, and to be safe, you should do a deep copy. If you don't want to worry about all of the details of whether you need a regular copy or a deep copy, you can always just do a deep copy and be more comfortable. Then I can change copy list's third one to 5 and display copy list here. And now when I run it, okay, before the function 1, 2, 3, 4, 5, inside the function copy list has been changed, but then when I come back outside, my list is not changed. Okay? Now, you have to do the copy. If I just simply did equals, that wouldn't do it. That's not going to do it. It's changed outside if I use the equals sign. Equals does not create new memory for copy list. Copy list just simply points to the same thing that input list and my list all were. So don't use that equals sign. Unless you ask for a copy of that thing. Doing this one gives you where it's not changed in the global scope. Okay? Yes?
The caret is apparently an XOR.
XOR. Okay, so it's an exclusive OR. Caret is the exclusive OR for logical stuff.
And you can just type in help like you can in MATLAB too.
No, you don't say.
Help, parentheses, and the single quote.
Well, isn't that cool? So here's all we ever wanted to know about range. That's cool. Did not know it. See, they stole something else from MATLAB. There's lots of stuff they steal from MATLAB. It's kind of cool. All right. Any questions? Okay. Should we have a look at? Yes. Go ahead,
Is
Joe.
there like a break, like a debugging where you go step by step?
No, there is no debugging. Not with idle. Okay, but Jacob, what did you want to add?
I was gonna say Anaconda, they kind of have like a partner IDE I just found in the menu. It's called Spider.
Okay.
It basically looks like someone said, make an IDE that looks exactly like MATLAB, but make it from Python.
Yeah.
So it does have debugging.
Okay. So he's saying that that Anaconda has a add-on tool. Now you have Miniconda installed, and Miniconda is sort of a bare bones version of Anaconda. So I wonder if you maybe can run Spider with Miniconda. Maybe we'll have to look and see.
If you just do conda install Spider,
Yeah.
it does install straight from Anaconda.
So if we do that from, you're saying to do that from the command line here. Have you tried that with your Miniconda installation? Conda install. Is it what the Y?
Yeah, it'll plug there. It takes like a minute or two.
Okay, so it looks like that won't be too much work. That's great. I'll have to look into that to see how we can use Spider, because that's one of the big pet peeves I've had with Python is it's not easy to do debugging. You have to write print statements everywhere, sort of old school debugging style.
Spider is a debugger.
I don't know. That's what he's saying. This Spider is some sort of a debugger. So I'll have to try that out and see.
It has the variable window. In the,
Okay, so it has like a workspace window. It makes it look kind of like the MATLAB stuff.
you can edit the
Cool.
variables straight to workspace. And you can block it.
Very cool. So I'll have to look into that and see see how that works. Did you have another question or comment, Rusty? You cannot. Or you're saying you can? You can right-click and do a set a breakpoint? Huh. Okay. Well, it ran the whole thing. Let's see. Can we do? What does check module do? That just checks syntax, I guess. That's interesting. I don't know. So we now have a breakpoint, but I don't know how to make it go into debug mode.
Well, if you just go into the shell, you can hit. There's a debug on top. Then you can right-click,
Maybe.
or you can go to debugger.
Hmm.
I don't know how it would work, but
There.
it is.
Well, I have not used that, so I don't know. I don't know how it works, but it looks like there's some way to debugging. My guess is that the Spider thing is going to be way better than this, because most people that program in Python, they kind of turn their noses down at Python at idle. They think idle is pretty simplistic. I was trying to keep it simple for us, but I think maybe looking at Spider is probably a good idea. So let me have a look at that, and we'll see if we can.
On note 2,
Get that
close
to work.
CMD, you lose your file.
Yeah.
Just found that one out.
Right. Yes, you don't want to close your command window.
Close CMD. you lose
So, and since you already have Miniconda installed, it looks like, getting Spider in there is not a big deal. So that's kind of cool. Yeah, Taylor.
I noticed on Visual Studio that there was something for Python.
Yes.
To install it.
So apparently you can run Python in Visual Studio.
I'm downloading the thing right now. to see
Yeah.
if it's gonna work.
So you can put Python into Visual Studio, and surely it has some sort of debugger for it. So that's an option as well. Yeah.
So I should say,
Jake.
you just run it straight like Python.
Just type in Spider.
It takes a minute to open, but
Okay.
Pretty.
Yeah, very pretty. Visual Studio, I think most of the people that do stuff in Python, I think they would probably not be happy about Microsoft taking over Python stuff. Python is sort of like a open source free type thing, and I've not ever seen anybody use Visual Studio, but maybe that will get more popular. I don't know, especially because a lot of people run Python on Linux, and so I'm not sure how popular that's going to get, but it is definitely an option. So yeah, this looks a lot more like like say like the MATLAB window.
the variable explorer, where the help window is on the right, you go down
Ah, yeah.
There's zero floor command line to the bottom right.
Gotcha. Very cool.
Oh, that's very MATLAB-y.
Yeah, very MATLAB-y, isn't it? And so then here's your P. Yeah, so the x is equal to 5, 6, print x, y is equal to 10, then run. Now x and y are in the workspace, 6 got printed on the screen, so yeah. So you can see there's a lot of MATLAB parallels.
Right click the variables, it's in the workspace, and you can like
So you-
get a list. You can just hit right click and plot or histogram, it just pulls up a window like that.
Yeah, cool. So this is maybe the way to go, better than using idle, you know. And since you've already got Minicond in there, just install Spire like we did, and we're good to go. Thank you very much, Jake. Appreciate it. See, this is great. We're all learning together. Wonderful. Okay. So have a look at the homework. Let me know if you have any questions, and we got to get started on that.